Hey guys, and welcome back. So today, actually, before we get started, I just kind of want to recap what we've been talking about because I know it's been a few days since any of us have even looked at this. So where we left off last week, we started our chapter or our unit on the endocrine system, and we talked about how this is considered the slow control system of the body, whereas the nervous system would be the fast control system. And that's because this is going around, it's doing a lot of controlling and things like that, and the way it does that, like we said, was with hormones. Hormones are those messengers that are going to be going out through the blood and taking that message. And once that message gets to wherever it's going, we figured out that there was one of two ways it could get that message in there, which is what we talked about last week, which was either direct gene activation or the second messenger system. And I'm not going to go through each and every one of those again. Because they're in some ways self-explanatory. Direct gene, the hormone goes directly into the cell and directly affects the gene that activates it to start making a protein. And the second messenger system, it can't do that. And so it relies on a second messenger, a man on the inside, you could say. And so again, if you want to refresh your memory on those, you can go back and watch that video. But that's all the farther we're going to get into that today, because today what we're going to talk about is how these hormones got there in the first place. So we talked about, yeah, these are how the hormones are getting there, but what actually causes the hormones to be released in the first place to go to these target sites? And a lot of that has to do with what's known as negative feedback. Now, if you remember last week, I told you guys this is where we're going to be picking up, and I told you you could kind of go ahead if you want to and watch that video from the Amoeba Sisters. If you have not done that yet, please stop this and go and watch that video right now, because what that video talks about is negative feedback. And so I want you to go ahead and watch that because it's going to discuss negative feedback and positive feedback. And then when you do that, you can come back here and we're going to get started. Alright, so I'm just going to assume that you paused the video or you've already watched it, and we're just going to keep going. So like I said, last week we talked about, what the endocrine system is and how these hormones are traveling. But what is it that triggers the release of these hormones in the first place? Well, it's this idea of the negative feedback. If you watch the video, uh, you might have heard them talking about the idea of like a thermostat, and that's honestly the easiest way that I can think of for discussing what negative feedback is talking about a thermostat. In other words, you have an air conditioner in your house, and if it gets too hot, your thermostat realizes that and it's triggered to put the AC on. And it knows that it's going to try and cool the house to a certain temperature, maybe let's say 72 degrees. And once it's cooled back to 72 degrees, that negative feedback is going to kick in again and tell it to stop. Then when it gets hot again, negative feedback is going to tell it we need to get cool again, so on and so forth. It's the same thing that happens with heat. And if you guys have remembered, I've told you guys several times already about the great burning in our classroom, where the negative feedback on my thermostat wasn't working during the winter 2 years ago. And so what happened was, when our heat, it was supposed to cut off at 72 degrees, that negative feedback wasn't working. And so it just kept getting hotter and hotter and hotter until it got to over 130 degrees in the classroom, which unfortunately was not good for all of our poor little critters that were in there. But nonetheless, it's a great example for explaining what happens when negative feedback doesn't work properly. And it's the same thing within our bodies, and that comes into play with some of these diseases that we're going to see that come up when negative feedback isn't working. And so this whole idea of negative feedback, what's happening is it's either going to drop in a level or get too high in a level of something, whether it's a hormone or a chemical in the body or just a reaction. And when our bodies either increase in these levels or drop in those levels, it's a change within that internal balance. And if you remember back when we were talking about the nervous system, anytime we talk about a change or the change in the environment, we're going to call that a stimulus or a stimuli. All right? And that's key because now what we're going to go into talking about are the different types of stimuli that are going to affect the negative feedback of these hormones. And there are three main types of stimuli that are going to do it. There's going to be hormonal, humoral, and neural. And so that's what we're going to look at today, are those three different types of stimuli. All right, so the first type is hormonal. And what happens with hormonal? This is the most common one, again, because we're dealing with the hormone system. And what goes on here is simply this idea that we have hormones that are going to be released from one gland. And those hormones start traveling through the blood. They get to their target site. That target site is probably going to be another type of endocrine gland. And when those hormones get to that endocrine gland, those hormones are going to tell that gland to activate and start producing or releasing another type of hormone. And then those hormones are going to go on somewhere else. So an example of this would be, it's not necessarily what's showing on your screen right now, but the hypothalamus. If you remember when we talked about the brain, the hypothalamus, that's that part inside the diencephalon that is kind of giving us some of that limbic system, some of that reward center. And so what happens is you're going to have hormones coming from the hypothalamus that's going to affect your pituitary gland. And then that pituitary gland is going to send out hormones to lots of different places in the body. I know a lot of these might kind of sound foreign to you, like what is the pituitary gland, what are pituitary hormones, and we're going to be getting into that later on this week, but this is just a basic broad example. So let's say that, you are really happy or you do something that's good, and so the body rewards you with that dopamine. That dopamine is going to release and then it's probably going to trigger something in your pituitary to release other hormones. And then those other hormones are going to activate other sites in the body. That's a change. It's a negative feedback change that's happening with hormones, and so that's why we call it hormonal. And the next type, sometimes a lot of people get it confused or mixed, and I know I've done it before too, just saying it because they look very similar. We have hormonal here, but the next is the humoral. All right, the humoral stimuli. And what humoral is referring to is a fluid. If you remember at the very beginning of the year, we talked about some of the ancient, not contradictions, but flaws, I guess you could say, in very early anatomy. What the ancient Greeks thought about how the body worked was on these different fluids, and if you had too much of a certain fluid, then that was what was causing you to be sick, and those fluids were what we considered the humors. And so when we're talking about a humoral stimuli, what we're talking about is a change within one of these fluids. All right, this can often be confused sometimes with the hormonal, because aren't hormones traveling through the blood? And the answer is yes, hormones are traveling through the blood, and so are the different chemicals that are going to affect humoral changes. However, the easiest way to remember it is that when we're dealing with humoral stimuli, we're dealing with certain ions or chemicals that are not hormones that are going to be doing it. And so one of these examples would be with our insulin. In other words, if we have too much sugar in our bodies, then our bodies are going to be triggered to release that insulin. However, if you have
diabetes,
your bodies aren't going to be able to produce that insulin all on their own, so they're going to need some help. And that's why diabetics have to take insulin shots and things like that. But nonetheless, that's just one of those examples of a humoral one. And so what's going on with the humoral is it's just the levels of chemicals or nutrients, ions that are in the blood. When those change, that's going to trigger these endocrine glands to release certain hormones like insulin or parathyroid hormone. And again, this probably doesn't make much sense to you right now because we're going to be talking about this later on. We'll be getting to this one sometime later next week. But what this is talking about is the amount of calcium in the blood. And I believe our next slide here shows us that. So what's going on here, just following our figure here, we can see that there's a low concentration of calcium in the blood. And so what's going to happen is because there's this low concentration of that nutrient in the fluid, in that humor, all right? Humoral refers to the fluid, so there's a low concentration of calcium in that fluid. It's a humoral change that is going to trigger the parathyroid gland to release the parathyroid hormone. And long story short, what parathyroid hormone is going to do is it's going to go to places like your bones, and it's basically going to tell those osteoclasts to start breaking down the bone to release the calcium. That way we can get that calcium level right back where it needs to be in the blood. Once it gets to that certain point, the negative feedback is going to tell it to stop, and that's how the humoral stimuli are. And then last but not least, our neural stimuli. So when somebody comes up behind you and scares you, or when your cat happens to see a cucumber, or anything that is going to trigger that fight or flight response, that is going to be what we consider the neural stimuli. And this doesn't really trigger much except for that response. Because what's happening with the neural stimuli, what makes this so different between a humoral and a hormonal stimuli is that it's the neurons that directly send the signal to the gland. Whereas the other ones are relying on the blood to take their message, the neurons here are sending that signal straight to the adrenal glands located like on your kidneys and telling them, hey, you need to release that hormone and you need to do it now. And the reason they do that is, again, because this is our fight or flight. Our neurons, remember, that's the fast control system. And so if you have something coming towards you or you hear a loud noise, your body instantly goes into protection mode or survival mode. And it thinks, what's going to happen to me? I need to protect myself. And so it's going to send that neural signal down to the adrenal glands to release that epinephrine and norepinephrine. And these are your fight or flight hormones. This is that adrenaline that helps you to either run away really fast or to stand and fight. And that's why it's extremely important that it's the nervous system that is sending that signal, because it has to be fast. You have to be able to respond instantaneously almost. And so, just to recap what we talked about today, the three main stimuli, in other words, the three main changes within your body that are going to trigger the releases of hormones, the most common is going to be hormonal stimuli. In other words, we might see an increase or a decrease of a certain type of hormone, and so that's going to trigger other hormones to be released. It could be humoral, where if you have certain levels of nutrients in the blood, whether it be too high or too low, that's going to trigger the release of more hormones. And then last but not least, if something triggers that fight or flight reflex, that neural stimuli is going to respond, and it's going to trigger the release of these hormones to help you with that. So that's actually it for today. Pretty short. And if you have any questions, again, just send me a message through Remind. Let me know. Maybe we'll get to talk about it during the Zoom or during our YouTube Live. And again, if you have any questions, I'd love to hear those. So I'll talk to y'all later.